we're back. Oh, I'm gonna turn the light on. 1 second. Hope to see a little bit better. Cool. My shower is fixed. I'm not sure if I had mentioned it before, but yeah, there was previously no handle, and he had gone to the store to get a longer screw so he could put a new handle on the shower. Now we have a handle. The shower works again. It's amazing. Okay, so I went ahead and I ran this prompt, and I did add my my key to Git, so it's in there, it's running, it's good to go. So we're gonna go ahead and I'll just show you what I had done. So if you go to the drop down, has settings, and then in here you go down to SSH and GPG keys, and then you can add your SSH key, you title it whatever it is. I didn't really change that. And then from your terminal you run this line of code, and it will populate what needs to go into here. So now that we have that set up, what we're gonna do is test it. So we're gonna test the key. I've pulled up this article from GitHub about verifying the SSH connection, and hopefully we'll see this first try. If not, then we'll have to troubleshoot, but hopefully. Fingers crossed. So we are going to put in ssh-t git at github.com. Okay, we're seeing a warning. Yes, I want to actually, we're supposed to verify that it is the public. Fingerprint is SHA65 plus DY ending in QU. Great. Perfect. Yes. Okay, we have permanently added GitHub to the list of known hosts. Successful authentication and does not provide shell access, but we already knew that, so we can exit out of that, and then we'll mark this lesson as complete. We've now officially finished the prerequisites. I'm very proud of us. And we can go ahead and move on to the next section. Next lesson. Okay. Introduction to Git. So Git is like a really epic save button for your files and directories. Officially, it's a version control system. A save in a text editor records all of the words and documents in a single file. You're only ever given one record of the file, such as sa.doc. Unless you make duplicate copies, which is difficult to do and keep track of. However, a save in Git records differences in files and folders and keeps a historical record of each save. This feature is a game changer. As an individual developer, Git enables you to review your project grows how your project grows and to easily look at or restore file states from the past. Once connected to a network, Git allows you to push your project to GitHub or alternatives such as Bitbucket, Beanstalk, or GitLab for sharing and collaborating with other developers. Please note we only support GitHub with our current curriculum and will not help troubleshoot with alternatives. Cool. While Git works on your local machine, it is a remote storage facility on the web for all your coding projects. This means that by learning Git, you will get to showcase your portfolio on GitHub. Woohoo! This is really important because your software development companies consider using Git to be an essential skill for modern web developers. Having a GitHub portfolio will provide proof of to future employees as to what you are capable of. In this lesson, we will briefly explore the history of Git, what it is, what it's useful for. In the next lesson, we'll go over a basic Git workflow for using Git, which should enhance your understanding and demonstrate why it's so useful. So I'm going to get I'm going to stop throwing things. Those are all my algorithms notes. I'm writing them down, not on our handy dandy legal pad, but instead in a spiral bound as I've been reading through the algorithms book. Start a new page. So this is going to be our notes on Git. GitHub. So the lesson and the third lesson, so we're on lesson 1. Lesson 2 goes over history of Git, what it is, what it's useful for. Lesson 3 will go over basic workflow using Git, which should enhance our understanding and demonstrate why it's so useful. And then fourth and finally, we'll set up a project with Git that will serve as a template for future projects, which is great. So today's lesson this lesson's overview contains a general overview of topics that you will learn in this lesson, explain what Git and GitHub are and the differences between them, and then describe the difference between Git as a text editor in terms of what they save and the record keeping, and then describe why Git is useful for individual developer and a team of developers. Whew, so we're going to read a book. Are you ready? Because I'm ready. I'm going to exit out of GitHub. So that's first thing is this book about version control. Then we're going to watch a video about how Git can improve workflow. I'm just going to pause. I'm going to load in and then pause. We're thinking about it. We did it. Cool. And oh, it said no thank you. Hopefully that's not copyrighted. Okay. And then this video for history on GitHub. Sometimes I can't speak. I think this is a through line of our time together. You will maybe have seen in previous streams, but sometimes I forget how to speak. It's great. So that's the third one. Cool. Oh yeah, there's a whole series on it. That's cool. I like that. Then if you haven't installed Git, you're setting up Git, but I'm pretty sure that's what we just did in the last lesson. And then we'll take at Odin Project's GitHub repository. This is where all the lessons are stored. And then while we look there, we'll look at the collaborators to gain an appreciation for how Git records all collaborative efforts and how GitHub visually represents this. So I might do that one first. Seems a little more straightforward. I've definitely seen one of these before. I'm currently working through one for the algorithms book because a whole bunch of the answers to exercises are in a GitHub repository, much like this. Yeah. Same as those developer roadmaps that I had pulled up before in a previous episode, previous stream. It's a similar repository like this. So this this has all of the lessons, all of the different paths, and then it in total has just under 60,000 commits, which is pretty cool. There's the main URL, all of the tags, and then here are more than 5,000 contributors. So cool. And then here underneath it is just a little summary, the README about the Odin project. Yeah. Cool. So we did that one. We're coming back for this, but I want to roll it back to the start. There we go. Cool. So we'll come back to this knowledge check after we have read everything, but we're going to start by hopping into 1.1 through 1.4, I believe it was. Yes. Here we go. I'm going to take a drink before I... This is just hot chocolate. Because I have a sweet tooth. You know. You know. I have been getting really... This is like way far out and I shouldn't even be thinking about it yet, but I can't stop myself. So, I've been getting excited lately about the prospect of someday being a developer. Before I was kind of just like a little curious about it, you know, like what if I could do this? That would be kind of cool or whatever. But now I'm like, what if I did this? What if in like a year, instead of walking through these Odin project lessons, I was doing an interview. Okay. Getting started about version control. This chapter will be about getting started with Git. We will begin by explaining some background on version controls tools, then move on to how to get Git running on your system, and finally how to get it set up to start working with. At the end of this chapter, you should understand why Git is around, why you should use it, and you should be all set up to do so. About version control. What is version control, and why should you care? Version control is a system that records changes to a set of files or set of files over time so that you can recall specific versions later. For the examples in this book, you will use software source code as the files being version controlled, though in reality, you can do this with nearly any type of file on a computer. If you are a graphic or web designer and want to keep every version of an image or layout, which you most certainly want to do, use a version control system, VCS, is a very wise thing to use. It allows you to revert selected files back to a previous state, revert the entire project back to a previous state, compare changes over time, see who last modified something that might be causing a problem, who introduced an issue and when, and more. Using a VCS also generally means that if you screw things up or lose files, you can easily recover. In addition, you get all this for very little overhead. Local version control systems. Many people's version control method of choice is to copy files into another directory, perhaps a time-stamped directory if they're clever. This approach is very common because it is so simple, but it's also incredibly error-prone. It is easy to forget which directory you're in and accidentally write to the wrong file or copy over files you didn't mean to. To deal with this issue, programmers long ago developed the local VCSs that had a simple database that kept all the changes to files under revision control. So you can see here, local computer, there is a file, and then the version database, version 3, 2, and 1. One of the most popular VCS tools was a system called RCS, which is still distributed with many computers today. RCS works by keeping patch sets, that is, the differences between files, in a special format on disk. It can then recreate what any file looked like at any point in time by adding up all the patches. Centralized version control systems. So the next major issue that people encounter is that they need to collaborate with developers on other systems. To deal with this problem, centralized version control systems were developed. These systems, such as CVS, Subversion, Perforce, have a single server that contains all the versioned files and a number of clients that check out files from that central place. For many years, this has been the standard for version control. Centralized version control. This setup offers many advantages, especially over VCSs. For example, everyone knows to a certain degree what everyone else on the project is doing. Administrators have fine-grained control over who can do what, and it's far easier to administer a CVCS than it is to deal with local databases on every client. However, this setup has some serious downsides. The most obvious is the single point of failure that the centralized server represents. If that server goes down for an hour, then during that hour, nobody can collaborate at all or saved version changes to anything they're working on. If the hard disk the central database is on becomes corrupted and proper backups haven't been kept, you lose absolutely everything, the entire history of the project except for whatever single snapshots people have on their local machines. Local VCSs suffer from the same problem. Whenever you have the entire history of the project in a single place, you risk losing everything. In comes distributed version control systems. Ooh. Cool. This is where distributed version control systems step in. A DVCS, such as Git, Mercurial, Bazaar, or Darks clients don't just check out the latest snapshot of the files, rather they fully mirror the repository including its full history. Thus, if any server dies, and these systems were collaborating via that server, any of the client repositories can be copied back up to the server to restore it. Every clone is really a full backup of all the data. So here it's just the diagram, or the figure, showing the server computer, which houses all three versions that have been worked on, and that database is then also on computer A and computer B, which can then, So sorry. And then that can then be re-uploaded to the server computer if need be. Furthermore, many of these systems deal pretty well with having several remote repositories they can work with, so you can collaborate with different groups of people in different ways simultaneously within the same project. This allows you to set up several types of workflows that aren't possible in centralized systems such as hierarchical models. A short history of Git. As with many things in life, Git began with a bit of creative destruction and fiery controversy. The Linux kernel is an open source software project of fairly large scope. During the early years of Linux kernel maintenance from 1991 to 2002, changes to the software were passed around as patches and archived files. In 2002, the Linux kernel project began using a proprietary DVCS called BitKeeper. In 2005, the relationship between the company that developed the Linux kernel and the commercial company that developed BitKeeper broke down. My mom is calling me. So, you're gonna hear what I sound like when I talk to my mom. 1 second. Hello, Mom. Is it what? No. You can answer that. I'll call you back. Got it. Okay. Burlingame. Yes. Yes. Yes, of course. Thank you. Bye. Okay. Sorry about that. Unprofesh. But cool. History of Git. So in 2005, the relationship between the community that developed the Linux kernel and the commercial company that developed BitKeeper broke down, and the tools free of charge status was revoked. This prompted the Linux development community, and in particular Linus Torvalds, the creator of Linux, to develop their own tool based on some of the lessons they learned while using BitKeeper. Some of the goals of the new system were as follows: speed, simple design, strong support for nonlinear development, so thousands of parallel branches, fully distributed, and able to handle large projects like the Linux kernel efficiently. So you needed speed and data size. Since its birth in 2005, Git has evolved and matured to be easy to use and yet retain these initial qualities. It's amazingly fast, it's very efficient with large projects, and it has incredible branching system for nonlinear developments. Cool. So, what is Git? Git in a nutshell This is an important section to absorb because if you understand what Git is and the fundamentals of how it works, then using Git effectively will probably be much easier for you. As you learn Git, try to clear your mind of the things you may know about other VCSs such as CVS, Subversion, or Perforce. Doing so will help you avoid the subtle confusion when using the tool. I have no experience with any of those technologies, so my mind is clear. Doing so, great. Even though Git's user interface is fairly similar to these other VCSs, Git stores and thinks about information in a very different way, and understanding these differences will help you avoid becoming confused while using it. Snapshots, not differences. The major difference between Git and any other VCS, Subversion and Friends included, is the way Git thinks about its data. Conceptually, most other systems store information as a list of file-based changes. These other systems, CVS, Subversion, Perforce, Bazaar, and so on, think of the information they store as a set of files and the changes made to each file over time. This is commonly described as delta-based version control. So check-ins over time, you have version 1, and then there's one delta, version 2, and then for version 3 there's a second delta, and then for version 4 there's another delta. You got the image. Git doesn't think of or store data in this way. Instead, Git thinks of its data more like a series of snapshots of a miniature file system. With Git, every time you commit or save the state of a project, Git basically takes a picture of what all of your files look like at that moment and stores a reference to that snapshot to be efficient if files have not changed. Git doesn't store the file again, just a link to the previous identical file that has already stored. Git thinks about its data more like a stream of snapshots. So this is the same type of, like the same number of changes have been made between these two systems. So you have version 1, all new drafts, and then A1 is a new version, so A1, no changes from version 2 to version 3, but then there was a change to A. I think you get it. I think you get it. This is an important distinction between Git and nearly all other VCSs. It makes Git reconsider almost every aspect of version control that most other systems copied from the previous generation. This makes Git more like a mini file system with some incredibly powerful tools built on top of it, rather than simply a VCS. We'll explore some of the benefits you gain by thinking of your data this way when we cover Git branching in the lesson of the same name. We're just going to scroll down. Okay, nearly every operation is local. Most operations in Git need only local files and resources to operate. Generally, no information is needed from another computer on your network. If you're used to a CVCS, where most operations that have network latency overhead, this aspect of Git will make you think that the gods of speed have blessed Git with unworldly powers. Because you have the entire history of the project right there on your local disk, most operations seem almost instantaneous. I will attest that working through servers is really slow. Or working remote through servers. For example, to browse the history of the project, Git doesn't need to go out to the server and get the history and then display it for you. It simply reads it directly from your local database. This means you see the project almost instantly. If you want to see the changes introduced between the current version of the file and a month ago, Git can look up the file a month ago and go to the local difference calculation instead of having to either ask a remote server to do it or pull an older version of the file from the remote server to do it locally. This also means that there is very little you can't do if you're offline or off VPN. If you get on an airplane or a train or want to do a little work, you can commit happily to your local copy, remember, until you get to a network to reconnect and upload. If you go home and you can't get your VPN client working properly, you can still work. In many other systems, doing so is either impossible or very painful. In Perforce, for example, you can't do much when you aren't connected to a server. In Subversion and CVS, you can edit files, but you can't commit changes to your database because your database is offline. This may seem like a huge deal. This may not seem like a huge deal, but you may be surprised by what a big difference it can make. So Git has integrity. Everything in Git is checksummed before it is stored and then referred by that checksum. This means it's impossible to change the contents of any file or directory without Git knowing about it. This function is built into Git at the lowest levels and is integral to its philosophy. You can't lose information in transit or get file corruption without Git being able to detect it. The mechanism that Git uses for this checksumming is called SHA-1 hash. This is a 40-character string composed of a hexadecimal characters, 0 through 9 and A through F, calculated based on the contents of a file or subdirectory structure in Git. A SHA-1 hash looks something like this. You will see these hash values all over the place in Git because it uses them so much. In fact, Git stores everything in its database not by file name, but by the hash value of its contents. Git generally only adds data. When you do additions in Git, nearly all of them only add data into the Git database. It is hard to get the system to do anything that is not undoable or to make it erase data in any way. As with any VCS, you can lose or mess up changes you haven't committed yet, but after you commit a snapshot into Git, it is very difficult to lose, especially if you regularly push your database to another repository. This makes Git a joy because we know we can experiment without the danger of severely screwing things up. For a more in-depth look at how Git stores its data and how you recover data that seems lost, see Undoing Things. The 3 states. Pay attention now. Here's the main thing to remember about Git if you want the rest of your learning process to go smoothly. Git has three main stages that your files can reside in. Modified, staged, and then committed. Modified means that you have changed the file but have not committed anything to your database yet. Staged means that you have marked a modified file in its current version to go into your next commit snapshot, and then committed means that the data is safely stored in your local database. This leads us to the 3 main sections of a Git project: the working tree, the staging area, and the Git repository. The Git directory. The working tree is a single checkout of one version of the project. These files are pulled out of the compressed database in the Git directory and placed on disk for you to use or modify. The staging area is a file generally contained in your Git directory that stores information about what will go into your next commit. Its technical name in Git parlance is the index, but the phrase staging area works just as well. And then the Git directory is where Git stores the metadata and object database for your project. This is the most important part of Git, and it is what is copied when you clone a repository from another computer. The Git workflow goes something like this. You modify files in your working tree. You selectively stage those changes you want to be part of your next commit, which adds only those changes to the staging area. You do a commit, You do a commit which takes the files as they are in the staging area and stores that snapshot permanently to your Git directory. If a particular version of a file is in the Git directory, it's considered committed. It has been modified and was added to the staging area. Again. Sorry. If it has been modified and was added to the staging area, it is staged, and if it was changed since it was checked out but has not been staged, it is modified. In Git Basics, you'll learn more about these stages and how you can either take advantage of them or skip the stage entirely. Alright, and then we have the command line. There are a lot of different ways to use Git. There are original command line tools, and there are many graphical user interfaces of varying capabilities. For this book, we will be using Git on the command line. For one, the command line is the only place you can run all Git commands. Most of the GUIs implement only a partial subset of Git functionality for simplicity. If you know how to run the command line version, you can probably also figure out how to use the GUI version, while the opposite is not necessarily true. Also, while your choice of graphical client is a matter of personal taste, all users will have the command line tools installed and available. So, we will expect you to know how to open Terminal in macOS or Command Prompt in PowerShell in Windows. If you don't know what we're talking about here, you may need to stop your research that quickly so you can follow the rest of the examples and description of this book. And I'm going to tab back to this. It looks like 1 through 4 was all we needed. I'll just click next to make sure that that goes on to 5. Okay, so we have done this already. This is what we had done in the previous lesson. We installed Git, and then the Mac OS install is cute. Okay, git config. We have done this. I'm going to exit out of this because I believe that Odin Project already guided us through what we needed to learn. So we're going to start at the beginning here. Hello. great. I'm going to make sure that our speed is a little higher because it's easier for me to follow along when it's a little faster. That's literally straight from the GitHub book. So I think we already know this. It's literally just what we had talked about. So I'm going to exit out of that one, say that we're good, thanks. Cool, so what kind of program is Git? It is a version control software system, my bad. And then what are the differences between Git and a text editor in terms of what they save and the record keeping? So Git saves snapshots of various versions. So every time a new version is made, it takes a snapshot, saves that the changes that have been made. And a text editor just saves what is currently in the text editor. So whatever file it is basically overwritten, and you cannot revert to an older version or see any of the changes that were made. Does Git work at a local or remote level? So Git works at a local level, but it does have a remote server. So there is, when you commit to Git, it is committing to your local server, but then also to the remote server, so that you have access to not only your local disk, but also Git. Does GitHub work at a local or a remote level? This one I don't know. It is remote. Cool. Why is Git useful for an individual? It's useful because it allows you to track your own changes, see how your projects evolve, and then, if need be, restore previous versions, so you can experiment around and figure out how stuff works and make improvements without fear of ruining your project. And then why are Git and GitHub useful for a team of developers? And that is because many developers can then can work on the same project at the same time, commit changes, and then see what other people are doing at the same time, so you know what people are working on. That improves like team functionality, and then you're all working on the same version or have access to the same version. It's great. So I'm going to mark complete because we have learned what it is. On to the next. Git basics. So in this lesson, we'll cover Git commands used to manage your project and upload your work to GitHub. We'll refer to these as basic Git workflow. When you're using Git, these are the commands that you'll use 70 to 80% of the time. So if you can get these down, you'll be more than halfway down mastering Git. This section contains a general overview of topics that you will learn in this section. How to create a repository on GitHub, how to get files to and from GitHub, and then how to take snapshots of your code. So before we start, GitHub recently updated the way that it names the default branch. This means that if you have an earlier version of Git, you need to update, and then if you haven't already, set your local default branch to main so that it's the same as the branch used by GitHub. For more information on the change from master to main, there's GitHub's renaming repository, and I am fairly sure that this is because master invokes some potentially discriminatory naming conventions. So many companies, both in GitHub and wider Git community, are considering renaming default branch of the repository from master. GitHub is gradually renaming the default branch on our own repositories from master to main. We're committed to the renaming process to make it as seamless as possible for project mainsters and all of their contributors. Yeah. So now we'll create the repository. You should have already created a GitHub account in setting up Git lesson. It was also listed in a lesson before the setting up Git lesson. So if you haven't made a GitHub account, GitHub. Get in the hub. I'm sorry, that was painful. Okay, create a new repository by clicking the button shown in the screenshot below. So we can go to GitHub. I have a pain in my back. GitHub. Cool. Well, click on this plus button and then new repository. Give your name, like git test in the repository name input field. Check add a readme file and then create the repository by clicking the green create button at the bottom of the page. So we are going to name this first rep. First rep. This is our first repository with Git. Add a readme file. That's what it said to do, yes. I guess I should call it a repo. Okie dokie. Now we're going to create it. It's being created. There we go. This will redirect you to your new repository on GitHub, which it has done. To get a copy or clone of this repository onto your local machine, click the green code button, then select the SSH and copy the line below it. Note you must click the SSH to get the correct URL. So we are going to click the green code button, select SSH, and then copy that. To get the copy the link. Now we'll use the command line. If I sing too much, let me know. I probably won't change it, just because it's a long time habit of mine, but I can try to do it less if it really annoys people. we're not supposed to do that yet. Let's use the command line on your local machine to create a new directory for all of your Odin projects. We are going to create a directory called repos with the make directory command in your home folder. So we're just going to open up this, and we are going just going to check where we're at. Okay, cool. Looks good. Looks good to me. Now we are going to make a directory called repos. Have done. Then we're going to move into it, so repos. Now we're there. Look at that. And now we're ready to move on. So navigating files and directories, I think that we've already looked into this. Yes. Covers variation of home folders. Sometimes tilde stands for user your name, and sometimes it stands for home your name. If you're not sure if you're in a home folder, just type cd. Once it's done, move into it with the cd command. So we have already done that. Now it's time to clone your repository from GitHub onto your computer with git clone, followed by the URL you had copied in the last step. The command should look similar to git clone GitHub username repository name. If your URL looks something like this, you have selected the HTTPS and not the required SSH option. So now we are going to get our terminal. We're going to copy that bad boy, or paste it, and enter poop. Code SSH copy this. So it says no file or directory. What did I do wrong? Yeah, GitHub. Okay, so now I'm gonna figure out what I did wrong. Is it potentially because my name is different? Because I did sign up the SSH in the previous lesson. So it's definitely not working either, because that is not what it's. So maybe I can say, ha, 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 I didn't read. It helps if you read. So now we're going to try this again, and it's working this time. So it's cloning. Just pasting the URL does not help it run a command on that URL. We figured it out. So now we have a successful clone. And we've connected the repository we created on GitHub to our local machine. To test this, we can cd into the folder that was downloaded and then enter git remove -v on your command line. This will display the URL of the repository you created on GitHub. Or not remove, remote. You may have noticed the word origin at the start of the git remote v output, which is the name of your remote connection. The name origin is both the default and the convention for the remote repository. But it could have easily been party parrot or dancing banana. So don't worry about those details right now. It'll come up near the end of the tutorial. So we're just going to test that we did it right. Okay, so now we can move into our first repo. Look at that. We did it. And then we'll say git remote -v, lowercase v, my bad. Yep. Amazing. Cool. So we'll create a new file in Git called hello world text or txt. So we are in our first repo local folder, and we're going to create hello world.txt classic. So now that we've created that, we'll type git status. In the output, our uncommitted, unstaged changes will show in red. So that is indeed what had happened with us. And then I'm going to change this my layout a little bit, because I want to be able to show both the command line and the instructions at the same time, like that. That is much better for me. Cool. So now that we have added that to our directory, we are going to type git add hello world.txt. And then we can type git status again. And now it just has that this is staged, but it is not yet committed, but it will be committed. So this command git add adds whatever we had indicated into the staging area. The staging area is part of the two-step process for making a commit in Git. Think of the staging area as the waiting room for your changes until you commit. When we checked it again, the file is shown in green. So sorry, I'm yawning so much today. Okay, and then we are going to type git commit -m, and then add our message. So add hello world.txt. Great, so we have committed our change. Now we're going to type status And it says our main branch, our on branch main, it's ahead by one commit. Use git push to publish our local commits, but there's nothing more to commit. Our working tree is clean, our staging area is clean because we have committed everything. Now we'll type git log. You'll see the detail on the author who made the commit, that was me. And then you can configure settings for this later. Great. Now we're going to open the README. So I'm going to clear this. It's a little messy. We're going to open the README. So we will type code, which opens VS Code. That's not what I wanted to do. Code dot. So what that did, cool, is it opened VS Code inside of our repository, so we didn't even have to go in and open our files or our directory. It just auto-populated the repository that we were in, that we wanted to be in. Before I mark this lesson as complete, I'm going to go back in and handwrite all of these commands that we've done because they are going to be useful. I want to memorize them. You know. So, if you're on Mac, go back to command line basics and follow the instructions to allow the git commands to work. I'm not working in Mac OS. I'm working on Linux, so this worked straight out of the box for me. And now we're going to open the README in our VS Code window. Yes, I am the author of this repo. Cool. So there's the name of our first repo. It's saying the comment that the description that we had added, and now we are just going to go down to line 3 and we're going to type hello Odin, because that's what it said to do. And now we will save with Control S. So Control S. Saved. Now we'll go back to our terminal, or if we're using VS Code, you can open the built-in terminal by pressing Control backtick. Nice. And then we'll type git status. And so you can see we have one change that is not staged and is not committed. So we're gonna so many yawns today. I'm so sorry. We're going to add to the staging area using git add and then the readme. Now if we do git status, it's going to tell us that it has been staged. And then, oops. So it did what it was supposed to. Sorry for all the scrolling. Cool. So we are still in our README file, so I'm going to enter, and now we are going to add some text to it and save it and stage it. So text is being added. This is very much not code. Huzzah. Then we're going to save, and then we are going to git add readme.md, and then git status. Look at that. Oops! I did it in the wrong one. Cut. Save. Hello world. We're gonna do two at the same time. Control V. Now we're going to say git add readme dot md space hello underscore world dot txt git status. Now we should have I thought I had done a cool thing, but then it didn't do the cool thing that I thought it did, so maybe I didn't save hello world in VS Code. That is what I did. I didn't save in VS Code. Important lesson to learn. We got it. Great. On to the next one. So finally, let's commit all the files that are in the staging area and add a descriptive message. So we are going to say git commit with two m's -m, and then edit readme.me and hello world.txt. Then we'll say git status, and that gives us that everything has been committed, nothing is in our staging area, and our branch is just ahead by 2 commits. So take one last look at our commit history by typing git log, and we should see 3 entries. I think that's probably fine though. So we're only seeing 2, but I'm not sure what this third one is because there was no comment. Hopefully it's fine. Now we're gonna push, so we're gonna type in, oh, that would be why. So there was the, Cool. Now we'll use git push. Okay, so it's just saying that it didn't publish my email address, which is what I had indicated that it should do. So we're going to type again git push origin main. So we're going to type git status, and we're still behind by 2 commits because of that email restriction. I'm going to see if it mentions it in here, because they were the ones who mentioned So I may just need to go into Git and then change my preference on that. So I'll go into Git. I'm gonna hide this right quick, like that. I'm gonna go into settings, emails, and then change this back to allowing command pushes that expose, because it's already been in the stream. Cool. I'll go back to profile and to my repo. And try that again. So we're going to git push. Oh, I should turn this back on, huh? Would be helpful. There we go. Git push origin main. We're committing. It's doing the thing. Fantastic. Now git status should give us that we're up to date, which it does. Fantastic. And then we'll just click in here and then reload. And now we have our repository is up to date. We have pushed our code, our README file, our little texts. It was not code, but that's fine. Yay! Now we can click into them if we want, but I think that's fine. I think that's fine. I trust that it's in there. Yeah, if we look at that. Great. Blame. Sorry. That was the first thing I saw. Blame. Amazing. Okay. Cool. When trying to make simple changes in the repo, such as attempting to fix a typo in your README, you might be tempted to make this change directly via GitHub. However, it's best to avoid this as it will actually cause issues that require more advanced Git knowledge than we want to go over at this stage. It's covered in a future lesson. For now, it's advised to make any changes via your local files and then commit and push them using Git commands in your terminal once ready. So this is our cheat sheet, which is what I had wanted to copy down. So I'm going to start doing that. These are our Git commands. So we're going to say Git clone. And then I'm going to put in quotation marks URL from SSH option. I feel like we're doing things. I mean, we haven't done anything yet. It's all still set up and learning how to use tools, but we're learning to use tools, so it's exciting. I don't know, I'm excited about it. Okay, git push or git push main. And then git add dot git commit -m and then quotation marks description. And then git status. And git log. So the basic git syntax is program action destination. I'm going to write that down. Program action destination. Cool. Yeah, that makes sense. That makes sense what it's saying. So it's saying that this is our standard pipeline. Git is the program being used, add is the action that we are performing, and then dot is the destination. So dot would be all the files within our current directory. Git best practices. There's a lot to learn about using Git, but it's worth taking time to highlight some best practices so you can be a better collaborator. Git is not only helpful when collaborating with others, it's also useful when working independently. You'll be relying more and more on your own commit history in the future when revisiting old code. 2 helpful best practices to consider are atomic commits and leveraging those atomic commits to make your commit messages more useful to future collaborators. An atomic commit is a commit that includes changes related to only one feature or task of your program. There are two main reasons for doing this. First, if something you change turns out to cause some problems, it's easy to revert the specific change without losing other changes. And second, it enables you to write better commit messages. You'll learn more about what a good commit message looks like in a future lesson. Changing the Git commit message editor. If you're using Visual Studio Code, you should be if you're following this curriculum. You don't want to get stuck writing a commit message in Vim because you accidentally used git commit without the message flag -m. This command will make Visual Studio Code open up a new tab with the ability to write your commit message and an additional description below it: git config global core.editor code -- wait. There will be no confirmation or output on the terminal after entering this command. To make a commit with Visual Studio as the editor, make sure to use the git commit command without the -m flag. Just type git commit and no message after that. Once you do this, a new tab will open. Now you can write your message and provide more information if you want right below it. After typing your commit message, save it and exit the tab. With that out of the way, you can now choose to either git commit or git commit within Visual Studio Code. Before we leave, I'm going to find the shortcut. Actually, I can just Google it. VS Code shortcut. Control plus tick. Control tick. I'm going to write that down. Cool. You may not feel completely comfortable with Git at this point, which is normal. It's a skill that you will get more comfortable as you use it. The main thing to take away from this lesson is the basic workflow. The commands you've learned here are the ones you'll be using most often within Git. Don't worry if you don't know all the commands yet, or if they aren't quite sticking in your memory. They will soon be seared into your brain as you use them over and over in future Odin projects. In later Git lessons, we will cover some of the more advanced Git features, such as branches. They will further expand your abilities and make you more productive. For now, concentrate on using the basics of Git that you've learned here for all of your projects from now on. I skipped the coffee today. I think that's what's doing it. You will soon know each of the Git basic commands from memory. Here's a knowledge check. So how do you create a new repository? You can go into your account and click new repository. It's easy to set up. How do you copy? So you type git clone and then you copy the URL from the GitHub page, paste it into your terminal with that git clone command, and then run it. What is origin within git push origin main? So this is telling it where to get the information and where to send it. So origin is the local file, and then main is then where it pushes to. Explain the two-stage system that Git uses to save files. Back down. So we use, it's kind of three, but I'll use it as two. So we stage, and then we commit, and then we push. So those are the steps. Those are a two-stage system. And that way we can check the status and see that we have X number of files that are unstaged, then we can stage them, and then we can commit them. But then once we've committed those changes, we still need to push to main. How do you check the status of your current repository? You type in git status, and then it logs the number of files and changes that have been made that are not staged or committed. How do you add files into the staging area? You type git stage. Then how do you commit files in the staging area and add a descriptive message? So there are two ways to do this. You would, in the command line terminal, you would, or in the bash terminal, sorry, you would type git commit -m and then parentheses, quotation marks, add whatever descriptive message you needed, then end quotation marks, enter. That would commit with that message. Within VS Code, you can do just git commit, and it should open up another tab, and then you can write your descriptive message in there, and then save and exit the tab, and that will save your descriptive message. And then how do you push your changes to your repository on GitHub? That is git push origin main, or just git push. And then how do you look at the history of your previous commits? Git log. Yay! I'm going to mark this one as complete. And lesson. I think we just finished Git. I'm going to scroll down here. It was just those two lessons. So we are starting on our HTML foundations. That was faster than I anticipated, which is very exciting. We're like actually doing things now. Sorry, we're just poking around. I hope I didn't just ruin that. We're coming close on. We're like at 2 o'clock, basically, which would normally be when I call it. But since the handyman was here, I'm just gonna grab some water, and we'll do this first lesson at least of HTML and CSS, because this is gonna be the start of something new. And I have to stand up because I keep yawning and I keep having my moment. So I'm going to stand up, get some water. I'll leave it running, but yeah, be right back. I had a fuzz on my shirt, and I like looked in the OBS, and I saw it, but I didn't know what it was. I thought that I had a hole in this sweater, but it's very new, so I was very worried for a second. Okay, here it is, time to start making things. This section will teach you the basics of HTML and CSS, the two fundamental building blocks for pretty much everything on the web. So this lesson is going to go over HTML, CSS, and how they work together. So HTML and CSS are two languages that work together to create everything that you see when you look at something on the internet. HTML is the raw data that a web page is built out of. All the text, links, cards, lists, and buttons are created in HTML. CSS is what adds style to those plain elements. HTML puts information on a web page, and CSS positions that information, gives it color, changes the font, makes it look beautiful. Many resources keep referring to HTML and CSS as programming languages, but if you want to get technical, labeling them as such is not accurate because they only are concerned with presenting information. They are not used to program any logic. JavaScript, which you'll be learning in the next section, is a programming language because it is used... Sorry, I read ahead. I shouldn't have done that. It's used to make web pages do things. Yet there is quite a lot you can do with just HTML and CSS. You'll definitely need them both. The following lesson focuses on giving you the tools you need to be successful once you get to JavaScript content as you continue through our curriculum. So our assignment here is to read this. It's an overview between the relationship between HTML, CSS, and JavaScript. And here are our questions. HTML versus CSS versus JavaScript. What's the difference? When you're designing or developing a website, there are 3 different coding languages to be aware of. HTML is the content and layout, so it determines how documents and web pages are displayed in a web browser. The language for... Oh my goodness! This is becoming a problem. Okay. CSS, style and look and feel. CSS, Cascading Style Sheet, is a popular style sheet language that determines how a document created in HTML is styled as far as like colors, font styles, layout, and responsive features. And then JavaScript, interactive elements. JavaScript allows you to change CSS and HTML elements on your website after the site has been loaded, which gives you the ability to make your sites more interactive and engaging for users. These 3 programming languages are typically found on any website, which is why it's important that you're aware how these affect your website and what they're typically used for. So HTML is hypertext markup language. It creates the structure, controls the layout, provides structure for the web page design, and the fundamental building block of any web page. Then CSS styles it, it applies style elements, it targets various screen sizes, and it primarily handles the look and feel. And then JavaScript increases interactivity, so it adds interactivity to a web page, handles complex functions and features, and then programmatic code which enhances functionality. Since I am not currently using VS Code, I'm going to slide this over. Great. What can you do with each programming language? With HTML, you will be able to create the structure of your website. CSS gives you the ability to make the website look more visually appealing. As for JavaScript, this is a robust programming language that allows you to effectively change the HTML and CSS components of your website to match your specifications precisely. If you own a website but don't know much about coding, knowing the difference between these 3 languages should help you get a better understanding of what goes into developing a website. If ever a problem occurs with a component of your site, having a clear idea of what these languages are may be enough to help properly diagnose what is causing the problem and how to fix it. so web development and coding languages. Websites can be developed with a wide range of different coding and programming languages, some which are more complex than others. Some of the most common web development languages include HTML, CSS, JavaScript, PHP, Python, Ruby, and SQL. While Ruby and PHP are exceedingly popular among entrepreneurs, startups, and web developers, the primary languages of HTML, CSS, and JavaScript should be enough for you to understand the basics of web design and development. Each of these web development languages has a different purpose. For example, Ruby is a scalable and fast programming language that can help you build an extensive website or program in just a short period of time. When paired with Ruby on Rails framework, this language gives developers practically everything they need to build a website. With languages like SQL, developers can maintain and optimize large databases in a much more streamlined manner. Different types of projects incorporate different languages of code. Many professional web developers also have their own preferences that they will use even if other programming languages have proven to be more popular. Various platforms are built on different languages. For example, WordPress is built mainly with powerful PHP code, even though HTML and CSS are used as well. The main language that you use all depends on your specific project and the business goals that you have. By identifying what these goals are, you should have a better idea of which languages are ideal when you are developing a website or application. So, what is HTML? It's a programming language that stands for Hypertext Markup Language. This is a relatively simple yet powerful programming language that allows web developers and website owners to create the structure of their websites. If you want a sentence in a blog post to receive a bold font, HTML could be used to achieve this. When using this system, any text files can be tagged for effects, graphics, fonts, or colors. If you've never used any kind of programming language in the past, HTML would be a great place to start. Keep in mind that HTML markups are enhanced by CSS and JavaScript, which is why it's recommended that you learn this programming language first. So what can you do with HTML? It allows you as a website owner to create the basic structure of your website, from which you can use any other coding language to enhance the design. With a basic understanding of HTML, you can significantly increase the control and flexibility that you have with your website. You'll be able to make your own changes by having knowledge of this code. Some platforms will automatically implement many of the more complex functions of a web design, which leaves you with the ability to tend to the minor changes that can be made with HTML. So CSS is a style sheet language that focuses almost entirely on improving the presentation of HTML elements. While CSS is a static programming language, it can be used to make your website appear visually pleasing and modern. If you want your website to have a sleek and stylish design, CSS is the programming language to use. With a basic understanding of CSS, you can change the overall look and feel of your website, which is useful when you want to match the appearance of your website with the aesthetic of your brand. I had read band like guitar band. So I was like, yeah, your band aesthetic. You got a heavy metal website. Kind of sad it's not that. What can you do with CSS? Even though it's primarily used to create static visual effects, the latest versions of the programming language offer some functionality for the creation of very simple animations. If you want to change the color of some text on a web page, basic CSS would allow you to do so by adding style code to the HTML code that's already found on your page. Along with the presentation of HTML, CSS... I'm really trying not to yawn anymore. Okay, along with the presentation of HTML, CSS can be used to alter the layout and formatting of your website. Once you know the basics of CSS, you should be capable of improving the look of your website and all of the HTML that you have already added to the design. JavaScript. It's among the most important programming language for website owners who want to make their site more interactive. which makes this the most complex of the 3 standard programming languages in this article. While HTML provides the structure for a website, and CSS allows you to control the presentation of a site, the JavaScript programming language gives you the tools that you need to alter the behavior of different elements that are found on a website page. With this tool, you can add a layer of interactivity to the CSS and HTML elements on your website, which is highly recommended if you want your website to appeal to the modern customer. Most modern websites come with a menu button that can be clicked to display a selection of areas on the website you can navigate to. The menu button usually reveals a small menu on the side of the page, which adds interactivity to the page itself. All of this is powered by JavaScript and can make your website appear to be more modern and sophisticated. With a basic understanding of JavaScript, you can manipulate the various interactive features of your website to perform a wide range of actions. If you want to have complete control over the design and function of your website, you should know at least some of the coding involved with JavaScript. So what can you do with JavaScript? The types of things you can do are practically limitless. This programming language can provide you with the tools needed to create a calculator for your website, create various keyboard shortcuts that allow users to effortlessly navigate to other pages, play animations when users scroll down the page, etc. Since you can change your HTML and CSS elements with JavaScript, this can be a very beneficial language to learn. So, best resources to learn web development languages. If you're looking to improve your knowledge and understanding of the many common languages used in web development, there are many fantastic resources that will allow you to enhance your skills in this area. No matter which programming language you want to learn, there are free resources all over the internet that will provide you what you need to understand the basics of the language in question. If you want to focus primarily on front-end development of website, use HTML, CSS, Bootstrap, and JavaScript. As for backend, you should consider learning languages like Python, Ruby, and PHP. The best resources available to you include free courses that will teach you the basics of the language in an organized and structured manner. If you want to learn how to effectively use HTML for your website, check out this course at Code Academy. By the end of the 9-hour course, you should be able to use HTML on your website without running into many issues. The same website also offers free tutorials for JavaScript, CSS. I've done some of the Python one. It has Ruby on Rails, it has C, and it has a whole bunch of stuff. I believe it also has SQL. While HTML and CSS courses have 5 and 6 lessons respectively for you to take, the JavaScript course is even more robust and includes 14 lessons with 30 hours of coursework. So the conclusion, HTML versus CSS versus JavaScript. While it is possible to develop and maintain a website for your business without having any knowledge of coding via a strong content management system, having a basic understanding of the more common programming languages will allow you to edit your current website or start building a new one without any assistance. Overall, you have more control over how your website looks, feels, and performs when you have some knowledge of these programming languages. Then they have related articles, but I'm not going to look into those. Great. So, knowledge check. What do HTML and CSS stands for? That's hypertext something language. Yes, and then cascade style sheet is CSS. And then between HTML and CSS, which would you use for putting paragraphs of text on a website? That would be HTML. Which would you use for changing the font and background color of a button? That would be CSS. And then what's the difference between these two in JavaScript? And that is that HTML is like what material goes into your site. CSS is like how it looks, and then JavaScript is how it functions. So this section contains helpful things. This is This article goes into more depth than the assigned one. Then this is massive API documentation collection that even works offline. It's an essential collection of reference material for everything covered. So I'm just going to save. Wow, there are quite a lot. Wow, it has like a lot of programming languages in here. Great. Welcome. Cool. Mark as complete. Alright, so hypertext markup language defines HTML defines the structure and content of the web page. So we'll use HTML elements to create all the paragraphs, headings, lists, images, and links that make up a typical web page. In this lesson, we'll explore how HTML works. This lesson contains a general overview of topics that you will learn in this lesson. Oh, I read that every time and I don't need to. So we'll explain what HTML tags and elements are. So, all elements on an HTML page are just pieces of content wrapped in opening and closing HTML tags. Opening tags tells the browser this is the start of an HTML element. They are comprised of a keyword and closed in angled brackets. For example, an opening paragraph tag looks like this, with the brackets and then a P in the middle. And then closing it is a slash and P. So a full paragraph would look like this. You can think of the elements as containers for content. The opening and closing tags tell the browser what content the element contains. The browser can then use that information to determine how it should interpret the format and content. There are some HTML elements that do not have closing tags, but these often look like follows. So br slash in brackets and then image in brackets, but some can also be used without the closing forward slash, such as br or img. These are known as self-closing tags or empty brackets because they don't wrap any content. We will encounter a few of these later in later lessons, but for the most part, elements will have both opening and closing tags. HTML has a vast list of predefined tags that you can use to create all kinds of different elements. It's important to use the correct tags for content. Using the correct tags can have a big impact on two aspects of your site: how they are ranked in search engines and how accessible they are to users who rely on assistive technology like screen readers to use the internet. The correct element for content is called using the correct one is called semantic HTML. We will explore this in much more detail later on in this course. So now we'll watch Kevin Powell's Introduction to HTML video, and we'll look at what is an we're just going to answer these right away. So an HTML tag is just it's the little bit in brackets that opens an element, and then you have your content and a closing tag, and that could be like paragraph, it could be header, it could be image, and that just tells HTML what we are trying to do, what type of content we are trying to add, and then what are the three parts of an HTML element, and that is just the opening bracket, the content in the middle, and then the closing bracket. Cool. Okay. So I'm going to mark that as complete. And I might actually call it here. Yeah. Yeah, I'm going to call it here because my yawning has reached peak levels. Yeah, I'm not sure what's going on with that. But we'll just peek right quickly at this list. So it's all of the tags that we could use. And then I believe these are all of them in alphabetical order. Yeah, cool. So if we needed to find specifically some specific tag that we needed to use, this would be a great resource. So I'm just going to do that and see what the next lesson is all about. Great. So boilerplate, and then the summary, introduction about this, and overview. HTML documents have the same basic structure or boilerplate that needs to be in place before anything useful can be done. In this lesson, we'll explore the different parts of this boilerplate and see how it all fits together. This section contains a general overview of topics you'll learn in this section. I read that every time and I don't need it. So how to write the boilerplate for an HTML document, and then how to open HTML documents in your browser. So creating an HTML file. To demonstrate an HTML boilerplate, we need to create a file to work with. Create a file on your computer and name it HTML boilerplate. So we're going to bring up our terminal. We're going to sorry, there was some weird noises happening outside. I'm going to make a file. I did not study. Literally the worst. Right. Touch HTML boilerplate dot. Okay, great. Oh, I want to leave my first repo. So cool. So I'm making a folder called HTML boilerplate. And then I'm going to move into it. And now I'm going to create our file called index.html. So we're probably already familiar with a lot of different types of files, for example, doc, PDF, image files. But to let the computer know that we're working with an HTML file, we need to append it with HTML. which is a great example of a file extension that has more than 3 letters. It's worth noting that we named our file index. We should always name the HTML file that will contain the home page index. This is because web servers by default will look for an index HTML page when the users land on our website, and not having one will cause big problems. So the doc type, every HTML page starts with a doc type declaration. The doc type's purpose is to tell the browser what version of HTML it should use to render the document. The latest version of HTML is HTML5, and the doc type for that version is simply doc type HTML. As listed below. The doc types for older versions were a bit more complicated. For example, this is the doc type declaration for HTML4, so doc type HTML public, and then a whole long line of text. However, we won't ever want to use that older version again, and so we'll always use doc type HTML. So open this in a text editor. So I'm going to bring up my terminal and type code dot. That pulls it up in my Visual Studio. And look, there it is. Amazing. Oh, I'm going to exit out of this one. Cool. Okay, we are open, and we're going to input our needs to be lowercase. Helps if it's lowercase. Great. So after we declare the doc type, we need to provide an HTML element. This is what's known as, I don't know why it's red. This is what's known as the root element of the document, meaning that every other element in the doc will be a descendant of it. This becomes more important later on when we learn about manipulating HTML with JavaScript, but for now, know that the HTML element should be included on every HTML document. So back in the HTML file, let's add the HTML element by typing out its opening and closing tags like so. So not only are we going to add great. I love this. It auto-completed it for us, so we didn't even need to type in the /HTML for the closing bracket. Amazing. It also put, cool. So language specifies the language of the text content. This attribute is primarily used for improving accessibility, which allows assisted technology like screen readers to adapt according to the language and invoke correct pronunciation. As someone who has used a screen reader, it's very useful. Head elements. So head element is where we put meta information about our website and stuff required for our website to render correctly in browser. Inside of the head, we should not use any element that displays content on the website. And then the charset meta element we should always have the meta tag for the char set encoding of the web page in the head element. Okay, cool. So we're going to make a head. And then we're going to meta char set is equal to UFT-8. Cool. Another element we include in the head of the HTML document is the title element. So we're going to add a title, and this will be named, oh, they have it all spread out. Title. Or we're just gonna I'm just gonna copy theirs. My cool. So following the head element, we'll create the body element, which is where all the content will be displayed for the users. So the text, the image, the list, and so on. So we'll add a body element to the HTML file. It goes within the HTML brackets, but below the head element. So it goes like this. Yep, just like that. And now, so viewing HTML files in browser. The HTML boilerplate in the index.html file is complete at this point, but how do you view it in browser? There are a couple of different options. So a note, in order to avoid branching our lessons instructions to accommodate for all of the difference between browsers, we're using Google Chrome. We strongly recommend you use this for your testing. So you can drag and drop from your text editor. I'm going to wait to do that. You can drag and drop an HTML into the address bar of your browser. It's beautiful. I don't think it actually changed the title though. Sorry. You can find the HTML file in your system and then double click it. This will open it in the default browser your system uses, and you can use the terminal to open the file in your browser. So for Ubuntu, we are going to navigate to our directory, but we are already currently in it. And then we are going to Google Chrome index. Oh, that's so nice. It just opened it in our existing browser. That was nice. It didn't open a new window. Very cool. So using the methods we've used, we'll see that it's blank. Yes, it was blank. Back in index, let's add more to the file. Oh, and they have this nicely spread out. I should leave white space. So we're going to add a heading. And I'm just going to open this again. Great. This is going to be H1. We did it. Okay. We're putting that in there. We're going to save. And then we're going to reload this. Has done. So VS Code shortcut. So VS Code has a built-in shortcut you can use for generating all the boilerplate in one go. Please note that this shortcut only works while editing a file in the HTML extension or a text file with the HTML code already selected. To trigger the shortcut, delete everything. Delete, and then we're going to type exclamation point. And then we're set up. Wow. That is so nice. But it's still good to know the boilerplate in case you find yourself using a text editor or a notepad or, you know, whiteboard in a job interview. Anything could happen. Try not to use the shortcut in your first few HTML projects so you can build some muscle memory for writing our boilerplate. So I'm not going to do the assignments just yet. I'm going to leave that for the next time. I feel like I've gone for a while now. Yeah, anyway, thank you for watching, and I'll see you next time. Ciao!